Okay, look, so just on the off chance that no one's ever thought of this before, um, I have figured out a way to translate a three-dimensional graph onto a two-dimensional plane. Planes are two-dimensional. That was redundant, but still, um, I don't know. It seems like it wasn't that hard to come up with, but it was hard enough to come up with that I wonder if anyone else has ever bothered. It is. Let me get date here. 9/3/2019, September 3rd, 2019. I. Yeah. So, how do you even explain this? Give me a second. I'll come back and explain it some more. But the point is, I just invented this, and maybe it's not original, but there it is. Right. And yes, I realize I'm recording a computer screen rather than just using a screen recorder. But I don't know. I feel really weird about this. I think that this should already have existed, and I have no idea where to even start looking for something like it. But here's the idea. I have a three-dimensional table. I have a cube comprised of cubic blocks, a 3 by 3 by 3 block stack, or yeah, whatever. Um, and if you were gonna model this in tables, maybe it would be like rows, columns, and layers or something. But it's a three-dimensional structure that I want to map onto a two-dimensional plane. So I don't know if this will help or hurt the understanding. If I take these things and I sort of shuffle them a bit. Um, so if I go back up to layer 9 here, um, what's the best way to do this? I'm just going to start striking things out as I go across them. So right here in the center of the thing is 111. If you want to go up let's see, we'll call that XYZ. So if you want to go up the x-axis to 211, you would go straight up. Up the x-axis is this way. So 211 is directly above 111. And this ring here is going to be 222, but we'll get to that later. The next up the x-axis is 311. And then, for whatever reason, 322 and 311 occupy more or less the same space on this, the way I charted it out. 322 is going to be superior to 311, I guess, but there's 322 right at the top crux of this thing. And actually, if we go one more step up, it becomes 333. So this outer ring here is 333. So we started at 111. If you could think of our, like, we have this sort of cubey thing. It's, I've drawn worse cubes in my life. I'm not too sad about that. And we've started here in the corner, and we've gone up the x-axis, which, if x is rows, well, I guess we've gone down, really. We've got 111, 211, so we'll call that right here, 311, 322, and 333 somehow. Anyway, but the whole idea is that we've got like an arrangement of these things, and I want to map this sort of cubey bit onto a flat space. So here we go. Anyway, we went up the x's first. Everything's 1. X is going to be our first variable, so x plus 1 equals 2. 1, 1, 3, 1, 1. And then I don't really know how to describe this relationship, but then it's 3, 2, 2. Like the x-axis, maybe, I don't know, couldn't go any higher. I haven't tried this with 4 layers yet, but then both the y and the z-axis increased for some reason. I don't really understand that, but let's keep going. if we go up the y-axis, so 1, 2, 1, so 1, 1, 1, 1, 2, 1. Y is going to be generally this way. This is going to be x for us, and this is going to be z. Anyway, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 1, 1, 1, 2, 1, 1, 3, 1. Going up y-axis now. 1, 3, 1. And then the y is now capped out at 3, so we're just sort of on the bottom row. 2, 3, 2. 1, 3, 1 or 2, 3, 2 all equals out to about the same. I understand now. Which is why I thought it sort of conflicted over here before. Anyway, 1, 3, 1 and 2, 3, 2. 1, 3, 1, 2, 3, 2. It's very late. I apologize. 2, 3, 2, and then 3, 3, 3 again. It was weird. Where's 2, 3, 3? It's down here. I'm not really familiar with the patterns yet. I literally just invented this thing. So, anyway, let's go up the z-axis now. 1, 1, 1 is where we start. 1, 1, 2, 1, 1, 3. And then for whatever reason, 2, 2, 3. This is looking sort of patterned up here as well. 2, 3, 3, and then we're back at 3, 3, 3, or 2, 2, 3, and then we're back at 3, 3, 3 again. Okay. The things in this first circle that we haven't touched on yet are, so we've got 1, 1, 1. We've got both z and y going up, brings us straight down. If both z and x go up, it brings us sort of up and to the left. If both x and y go up, it brings us sort of up and to the right. So we've got 1, 1, 1, also 1, 2, 2, 2, 2, 1, and 2, 1, 2. I'm not really keeping this in focus. I'm watching the screen more so than my phone. Okay. This ring here is going to be our 2, 2, 2. So every ring, every cube has its own, the full ring represents the cube. So anyway, 2, 2, 2 is where we're passing next. And then it's sort of like you're at 3, 1, 1. If your y goes up, you move a little bit to the right. If your or if your z goes up, you move a little bit to the left. Right? So starting from, well, here, where's 2, 1, 3 and stuff? Here, 1, 1, 3. So if x goes up, I'm going up a little bit. If y goes up, I'm going to the right a little bit. So 1, 1, 3 plus 1x is going to be 2, 1, 3. Here I am. 1, 1, 3. If you add a y, is going to be 1, 2, 3. So similar situation over here. 1, 3, 1 is what we had when we progress up the straight up the y-axis. 1, 3, 2 is going to be adjacent to it. Sorry, when you add one z, you come down and to the left, and when you add 1x, you go up. So 2, 3, 1. And then 3, 1, 2 and 3, 2, 1. I think we're getting this by now. Okay. So now we've got these three inner ones, each comprised of 2 3s and a 1. If I'm at 2, 2, 2, or I guess 3, 1, 2, 2, 1, 3. If I'm at 3, 1, 2, which is up here, and I increase 1z, then I go to the left and maybe a little bit down. If I'm at 2, 1, 3, and I increase x, then I go up. I am starting to be able to reckon my way around this. There's 3, 1, 3, and if we go up another x, or I'm sorry, How does that work? Somehow we've gone up a y. I've just transposed these is all. Honestly, don't remember which layer my thing was on. My labels. Okay, it's moved. Deselect. Give me this. Something like this. So now I got to redescribe the relationship that I was talking about when I said, oh, hey, I'm starting to get this, because that's now totally invalid. Okay, 3, 1, 2. Get out of my face, please. Go back up to our scratch pad layer so I don't screw anything else up. 2, 1, 3 becomes... I have to go up in X and somehow up in Y. Well, this is so counterintuitive. I almost feel like 2, 3, 2 should be somewhere else. Okay, how I figured this pattern out, let's just work it out here. 3, 2, 3 is going to be 3x, 2y, and 3z, which means the region that it spans is up here. Why is that inverse? It's directly inverse. So here's 2, 3, 2, and the opposite is 3, 2, 3. And then if you go down another y, we're going to come out to the edge. So we are going to flip all of these around. I just think that makes somewhat more sense. Oh, I gotta get on the right layer though. 8 maybe. There's probably a more efficient way to do this. But it's pretty late, and I don't care that much. I'll learn how to computer better tomorrow. I'm really kind of losing the plot on the phone here. So we want the lower x value to be further away from x. It's just, it doesn't, because it's a three-dimensional object and I've sort of stretched and squished it onto this two-dimensional space, it just doesn't make perfect sense. If I could ever get an intuition for how this works, I might be able to see in 4 dimensions. Like, somebody has to have thought of this before, and maybe somebody can even weigh in on, like, what order these are supposed to be in, or if I've just done this all completely wrong. Alright, going back up to the scratch pad. So, maximum x values are going to be 3, and all of those are on the side of the x. These all have maximum y values, these all have maximum z values. Okay, I'm starting to get this. Anyway, so 2, 3, 3 is maximum y, maximum z, so that's got to be here. And if we move down in x, we move further away. Maybe I should have left these two the way they were. I like the idea of moving down being moving further away, but let's see what else we've got in z. Z's 1, Z's 1, Z's 2 all of a sudden, and then it goes back down to 1. Yeah, I think I should have left those. Shuffle, shuffle, shuffle. Everybody back to your places. Let's replay that. Okay. I don't know. Anyway, where were we? 2, 3, 3 is going to be down here. Maximum z, maximum y. So right between z and y. 3, 2, 3. Maximum x, maximum z. That should put it here between x and z. 3, 3, 1. Maximum x, maximum y, minimum z. So closer to the inside of the circle. Interesting. So z goes up this way, but then also goes up eventually if you go this way far enough, because this is folding back around in on itself. This becomes like the adjacent cube to both of these cubes. Oh, I should have done something. I should have been paying attention to adjacency and stuff while I was up here. 331, maximum x, maximum y, minimum z is closer to the inside, 332 is closer to the outside. Okay, that's the gist of it, and I'm still learning so many things about this, but I tried, like, trivariate table, trivariate cube mapped onto circle. I didn't actually try literally cube mapped onto circle, and I want to do that now. This is going to be some graphics stuff. I just know it. Maybe if I didn't give Google riddles to answer. Mapping a cube to a sphere. Nope. Some explosives, but circle. The whole point is to go from 3 dimensions down to 2. I was doing this because I was trying to. I had like a table thing going on, you know, where you get your categories, and I'm losing myself in my own doodles now. 4, 5, 6, yada yada yada. A table, and I wanted to add the z index to the table, and I didn't know how to not have to just draw a bunch of cubes and like write everything on top of each other. Probably 27 would be the maximum number, so 27 minus 8 is 19. It's just this number plus 9. Okay, cube math. I'm learning so much about geometry. This is probably, somebody probably teaches all of this stuff in some kind of advanced geometry class, and I just missed it. I don't know what to call this structure. I don't know what to call this process of taking this and making it make any sense at all over. Oh, shoot. I wasn't on the right layer while I was messing around with all that stuff, y'all. Okay. Paintbrush, 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 paintbrush. Okay, I'm on layer 9 again. Anyway, I'm gonna just delete layer 9. So that's the gist. I want to know. Like, it makes sense that this is gonna be here again. X, Y, Z. This is 0 up in here, and this is infinity this way, etc., etc. So if Z is going up this way, why would it all of a sudden start to go up here? I need to put the 4th ring on this and see what the hell happens. The thing is, though, maybe it'll be fundamentally different, though. No, as long as it's still 3, as long as it's still columns, rows, and layers. Actually, layers would be more represented like this. As long as it's still columns, rows, and layers, no matter how big it is, it should always start at 1, 1, 1. Well, okay, let's just see. Let's just try this something out. The next, if I wanted to add 1, 1, 4 somewhere, 4 would be another ring, and 4, 4, 4 would be in this portion here. 4, 4, 4, which is fine. 1, 1, 4 would be this first piece right here. But then what else do I know? I know if I go, I'm as up as I can be in Z. If I go up in Y, both Y and Z jump, and then they go back down to 1. This is in the right order. This, I feel, is intuitively in the right order. This, I'm not totally sold on. Okay, but if I'm going toward y, then this is probably going to go up a little bit. It's probably going to be like 1, 2, 4. And then if we go up in y again, it's probably going to be 1, 3, 4. This is probably going to have to get split into 3 pieces, I would imagine. And it's going to be where z is maxed out and x is getting close to maxed out. So where would we put 4, 1, 4, 4, 2, 4, and 4, 3, 4? 4, 1, 4 is definitely going to be up in this region. 4, 2, 4 is going to be the same, and 4, 3, 4 is going to be the same again. So 4, 1, 4, 4, 2, 4, and 4, 3, 4 all have to be right here. And when you go up to 5, there's 4 of these, and there's... Okay, I mean, obviously there's a mathematical relationship between all of this stuff, so let's get the chicken scratch out of the way. Oh my goodness. Okay, so here in the center circle, if I only have 8, hold on, 1, 2, 3, 4, 5, 6, 7, 8. 8 is 2 cubed. I don't know why I'm drawing this. Everyone knows what a cube is. Well, I've gone too far now. You know, I've drawn worse cubes with a mouse. Okay, so there's 8 of these. 2 by 2 is 8, and we're golden here. That's as far as we get. If we add another layer... like this. We go up 1 layer, and now we have to bifurcate our triangle, and we have to give it 1 layer of flanks. So we have to add 3 to this, 1 to this. We add 3 to... we're adding 3 to this, so when this goes out here, maybe that'll be 3. And then there'll be... I need to like extend this as well, so that'll be some more. I need more patterns in order to really figure this stuff out. But 1 turns into 4, turns into what were we just actually looking at? Oh, you know what? I bet these will start to split. Meh. 1 turns into 2. 1 turns into 2. Maybe if you want to look at it that way, 1 turns into 2, 2 turns into 3. So yeah, I bet the next layer is going to be... let's try some 4s. Give me just a second. Okay, so I honestly have no idea what to expect, so we're just going to try some stuff. Going up the x-axis, what I would expect up here is 4, 1, 1. Ba-ba-da-ba-ba-da-ba. 4, 1, 1. As well as 4, 2, 2. Get out. 4, 2, 2, and 4, 3, 3. 4, 3, 3. All of them apex on the x-axis and have a negligible sort of y and z, such that... now the video was doing okay, and now it's getting harder to see again. Anyway, this will peak all the way out, and then of course 4, 4, 4 is the outer ring here. Okay, so that's something. One adjacent to these. So we've got 1, 1, 3, and 2, 2, 3. If only the z or the x went up, it went sideways. Because it was being pulled. Oh, if the x went up, it went that way. If the y went up, it went toward that. Okay, so I'm at maximum x now. So if instead of going to 4, 2, 2, finally went to 4, 2, 1 instead, I would be going up on the y-axis. I would expect that to be here, 4, 2, 1. And if I did this again, if instead of going from 4, 2, 2 to 4, 3, 3, I went to 4, 3, 2, I would expect that here, 4, 3, 2. And 4, 3, 4. 4, 3, 4 goes like over here somewhere. Okay, so 4, 2, 1, 4, 3, 2. That's all good. What about 4, 2, 2? That would be kind of like 3, 1, 1. Oh, 4, 2, 2 is already in there. How about 4, 2, 1? What about 4, 3, 1? Let's draw it maybe. 4 up here. Let's go to blue. 4, 3, 1. So this is going to come straight down here. This is going to pop over this away. And I don't understand. Maybe there's another sliver that comes. It would make sense if there was another sliver. It's just that my if this circle were bigger, this would line up better. But essentially, there's one more like this. And what did I say this was again? Text, please. This is going to be 4, 3, 1. 4, 3, 1. 4, 3, 3, no one cares about. 4, 1, 1, 4, 2, 1, 4, 3, 1. We're getting up in the y every time, and we're going toward y. Great and golden. 4, 2, 2, 4, 3, 2. We need to talk about 4, 4, 2. 4, 4, 2 is going to look like this. And it's going to, yes, occupy this space. So 4, 4, 2. Based on the pattern set out before, 1, 1, 2, 2, 3, 3. This is actually going to be 4, 4, 1 as well. And also 4, 4, 3. Okay, so now some more patterns are starting to emerge. We are always adding one layer of flanks. As we go out, we add one layer of flanks. We add one more section within the triangle facing directly toward the axis. So we got one section in this triangle here, 2 here, and there will actually be 3 sections here. We have 0 sets of flanks, 1 set of flank, one flanker on each side, and then 2 flanks on each side here. We have one area where we're maxing out the both variables on that side and minimizing it on the other side. We have 2 in the next one, and we have 3 in the next one. So all of these patterns are geometric. Ah, crap, I hope I didn't just use that word wrong. I would like the definition. In algebra. The pattern is defined as a series or sequence that replicates the sequence of objects that are arranged based on a particular rule known as a number pattern. Yeah, that is a geometric relationship. So we have a geometric relationship going out. You add one layer. You add, if we could get like some variables or something here. We have blue's fine. We have triangle sections. We have flanks, and we have flat sections. Just throw those up here. Every time you go up a level, you add one section to the triangle, you add one layer of flanks, and you add one layer to the flat section. Oh man, I did this wrong. Plus 1. Okay. So yeah, it's a three-dimensional table that you could, I mean, perhaps not very easily, but you could represent 3 dimensions worth of space and information. You could correlate things on 3 axes this way. And now let me see if there's anything that corresponds now to like a row. A row would be x's. So I've got where do my x's all equal 1? Give me another layer here so I can. Blue's probably still good. Okay. Red's a little easier to see, probably. So where my x's all equal 1 is going to be like this whole first side. That's just because of how I wrote it out, but it's fine. X equals 1, x equals 1, x equals 1, x equals 1, x equals 1. This is a row. What about where all the y's equal 1? Or I'm sorry, a column. Where all the y's equal 1. It's the second variable right here. This, they equal 1. Let's start that stroke over again. Alright, y equals 1, check, y equals 1, check, y equals 1, check, check, check. Then we come back, gotta come in tight this way. That is a column. Oh, you know what? And I bet if I did it where all the z's equal 1, it would be a shape sort of like bloop. Yeah. So more, less crappily. Let's try. Do I have a shape? I do have a shape. Okay, so a row is right about here-ish. Can't use the shift key without my hand. Columns right about here-ish. And layers right about here-ish. This is super sloppy, but it might make a cooler pattern than my squiggles do. Yeah, kind of a cooler pattern. Interesting. Interesting. So, can I build this into a data structure? Can I make a database that operates on 3 levels instead of 2? Rows, layers, and columns. What would that buy me? Why would I need a third? Because it can be both a relational and a transactional database at the same time? That's stupid. Relational databases can be transactional databases. Shit. I don't know practically why this helps me, but it solved a problem I had before, which is uh, trying to represent an object not unlike this, etc., etc., to be able to see all of the boxes simultaneously. So any value, any one of these 27 values in this 3x3 cube is somewhere on this, somewhere in this circle map. Is there any space maybe that would be more efficient than a circle for this? What if I actually just used a triangle? Maybe that would make these flat pieces make more sense. Y variable's holding steady and all of a sudden it jumps, and then it would actually go back down to 1, but then it would cook all the way up again, and go back down to 1 and cook all the way up again. Maybe if I used a different shape, this would make a little bit more sense.